Hey everyone, welcome back to our channel. Today, we are diving into an essential topic for Unity developers, the execution order of event functions. First, let's talk about what happens when a scene loads. Several key functions are called in a specific order. First up is awake. This function runs as soon as the script instance is loaded. It's called before any start functions, and it even runs when a prefab is instantiated. However, if a game object is inactive, awake won't be called until it's activated. If the game object is set inactive, then awake won't be called. The game object is skipped over altogether. If the game object is set active, but the component is disabled, awake will be called. Keep in mind, since awake is called before start, it's a good place to initialize variables that other scripts might depend on. However, you should be cautious about referencing other components or scripts that may not have completed their awake method yet. You can call awake from scripts attached to game objects that are inactive. This can be useful for managing data that should be initialized regardless of the object's active state. In summary, awake is a crucial part of the mono-behavior lifecycle in Unity, providing a solid foundation for setting up your game objects and their behaviors before gameplay begins. Next, we have OnEnable. This runs just after the object is enabled. So, if your script component is attached to a game object, this function will be triggered. OnEnable is invoked every time the script is enabled, which includes when the game object is activated or when the script's enabled property is set to true. Unlike awake, which is called only once during the lifetime of the script instance, OnEnable can be called multiple times if the game object is activated and deactivated repeatedly. It's often used for initializing components or starting processes that should happen every time the script is activated. This can include starting coroutines, subscribing to events, or resetting variables. A common use case for OnEnable is to subscribe to events. This ensures that the script can respond to events whenever it is active. OnEnable is called after awake, but before start. This means you can rely on OnEnable for setup tasks that need to happen before gameplay begins, but after all awake calls have completed. In summary, OnEnable is a versatile method for managing the active state of your scripts and ensuring that your game objects behave correctly when enabled. It's an essential part of the mono-behavior lifecycle that allows for dynamic interaction with the game's state. After loading, before the first frame update, we have start. This is called only if the script instance is enabled. The start method is called just before the first frame update, which makes it ideal for initialization tasks. Common uses of start include setting up references to other components, initializing game objects or variables, starting coroutines. The start method is executed only once during the lifetime of the script instance, which means it won't be called again unless the object is destroyed and recreated. Avoid heavy computations in start to ensure quick initialization. Keep it lightweight. Overall, the start method is a crucial part of setting up your game logic and is widely used in Unity development. Now let's talk about the update functions. First is FIxedUpdate. The FIxedUpdate function in Unity is a special method that is called at a fixed interval, independent of the frame rate. It's particularly important for physics calculations and is used for any game logic that requires consistent timing. FIxedUpdate is called at a fixed interval, by default, every 0.02 seconds, or 50 times per second. This is useful for physics calculations because it ensures consistent timing regardless of frame rate fluctuations. Any interactions that involve physics, like applying forces, moving rigid bodies, or checking collisions, should be handled in FIxedUpdate to ensure smooth and stable physics behavior. Using FIxedUpdate allows you to decouple physics calculations from the frame rate, which helps maintain stability in physics simulations, especially in scenarios where the frame rate may vary significantly. Always use FIxedUpdate for physics-related code. This ensures that the physics engine operates correctly and consistently. Since FIxedUpdate runs frequently, avoid heavy computations or calls that could slow down performance. In summary, Fixed update is a crucial part of Unity's game loop for managing physics-related tasks. By ensuring that physics calculations run at a consistent interval, it helps create a smoother and more stable gameplay experience. Next is the update function. The update function in Unity is one of the core methods in the monoBehavior class and is called once per frame. It is typically used for handling frame-dependent tasks and is essential for managing game logic that requires regular updates. Update is invoked every frame, making it suitable for tasks that need to be checked or updated continuously, such as player input, animations, and UI updates. Since update runs based on the frame rate, its execution frequency can vary. This means that code inside update can be executed a different number of times per second, depending on the performance of the game. It's commonly used for checking player inputs, like keyboard or mouse events, because it ensures that input is processed as quickly as possible, responding immediately to player actions. Avoid heavy computations or resource-intensive operations inside update to maintain good performance. In summary, the update function is fundamental in Unity for managing real-time game logic and responding to player input. By running every frame, it allows for dynamic and responsive gameplay, making it a key component in many Unity scripts. Next in the update functions is LateUpdate. The LateUpdate function in Unity is another important lifecycle method that is called after all update methods have been executed in a frame. It is particularly useful for scenarios where you need to perform actions after all other updates have occurred. LateUpdate is called once per frame, but after all update methods. This means that any calculations or adjustments made in update are finalized before LateUpdate runs. It's often used for camera follow scripts or any logic that needs to react to changes made during the update phase. For example, if a player moves in update, the camera can adjust its position in LateUpdate. Like update, LateUpdate is also frame rate dependent, but since it runs after all updates, it can be used to make adjustments based on the results of other update calls. Just like with update, avoid heavy computations in LateUpdate to maintain optimal performance. Use update for regular frame-based logic, fixed update for physics updates, and LateUpdate for adjustments that depend on the results of those updates. In summary, LateUpdate is a useful method in Unity for managing tasks that should occur after all other updates in a frame. It is particularly effective for camera movement and other follow logic, helping ensure that your game objects interact smoothly and responsively. Next is OnDisable. The OnDisable function is a special callback method that is called when a script is disabled or when the game object to which the script is attached is deactivated. This can happen in various scenarios, such as when you disable the component in the inspector, when the game object is set to inactive, or when the scene is unloaded. It's commonly used for cleanup tasks, like unsubscribing from events, stopping coroutines, or releasing resources that should not be active when the object is disabled. Since OnDisable can be called frequently, example, if a game object is frequently enabled and disabled, it's good practice to keep the code inside it efficient. It's paired with OnEnable, which is called when the script or game object is enabled. In summary, OnDisable ensures that the script does not continue to respond to events when it's not active, helping to prevent memory leaks and unintended behavior. Next is the OnDestroy function is a special callback method that is called when a game object or component is about to be destroyed. This can occur when the game object is explicitly destroyed using destroy, the scene is unloaded, and the game object is part of that scene. OnDestroy is typically used for cleanup tasks, such as releasing resources, saving state, or unsubscribing from events. It helps prevent memory leaks by ensuring that you properly clean up before an object is removed. This method is called just before the object is destroyed. It is not called if the application is quitting, but it is called in all other cases where the object is destroyed. Since this method can be called frequently, especially during scene transitions, it's essential to keep the operations inside it efficient. Unlike OnDisable, OnDestroy is only called when the object is being destroyed, not when it's merely disabled. If a parent game object is destroyed, all its child game objects will also have their onDestroy methods called. By properly utilizing onDestroy, you can ensure that your game maintains optimal performance and stability, especially during dynamic scene transitions or object management. And that brings us to the end of our exploration of the order of execution for events in Unity. We've covered key functions and how they fit into the overall lifecycle of a game object. Understanding this execution order is crucial for managing your game's logic effectively, optimizing performance, and preventing potential issues in your projects. Each function has its purpose and timing, so use them wisely to create smooth and responsive gameplay experiences. If you found this video helpful, please give it a thumbs up and share your thoughts in the comments. I'd love to hear which topics you want me to cover next. So don't hesitate to suggest your ideas. And remember to subscribe for more Unity tips and tutorials. Thanks for watching, and happy game developing.